Let's start. In the given figure, a circle touches all four sides of quadrilateral ABCD, whose three sides are AB equals to 6, BC equals to 7, CD equals to 4. Then AD equals to, always remember one basic, we have done this in our earlier video. Tangents to the same circle from a same point are always congruent, right? Now this same point will always be outside the circle, otherwise how can it be a tangent, right? So remember this and let's move ahead now. So what we get, AR equals to AS equals to X, assume. BR equals to BQ equals to Y, assume, right? CP equals to CQ equals to Z, assume. And DP equals to DS equals to P, assume, right? Now what is given? AB plus BC plus DC, because these values are known, equals to 6 plus 7 plus 4, right? Because it's given the values. Then therefore AB is what? X plus Y, plus BC is Y plus Z, DC is Z plus P, equals to 17. That is X plus 2Y plus 2Z plus P equals to 17. That is X plus 2 into Y plus Z plus P equals to 17, right? Remember our target. What we want? AD. AD means AS plus SD. What is AS? X, and SD is what? P. So we want X plus P. We have to anyways find X plus P. So in equation 1 we have got X and P. Now this Y plus Z we have to remove. So how to remove it? What is BC? BC means this B and C. So what is BC? Y plus Z. That is BC. And that is given as 7. So y plus z equals to 7. So 2y plus z equals to 14. Right? So input the value. Therefore, x plus p equals to 17 minus 14. Right? That is 3. Therefore, x plus p equals to 3. But what is x plus p? AD. So that's what we want. So that's the required answer. 3. Next, in the given figure, this figure, PT touches